Welcome to EDU World Space.
Hey guys, in this special relativity problem, we're asked to find the speed of light that would be measured by an observer on Earth if you're shooting that light from a spaceship cruising away from the Earth, right? So here's your setup. You have a spaceship here, right? Pardon my terrible drawing, but that's a spaceship, and it's moving away at 0.7 c. That's 0.7 times the speed of light from Earth, which is over here. Okay. Let's call this the Earth. Nice blue planet over here, and Earth. So the spaceship is moving away from the Earth, and then you have that a light beam is shot. Okay, you shoot a beam of light towards the Earth, so in that direction, and that, of course, will move at speed c because the velocity of light is the same everywhere, regardless of which frame the observer that measures that speed is in. And so that's one of the fundamental ideas of special relativity. Speed of light is the same everywhere. And so when the question has you answer what this observer right here that is standing on Earth will measure for the velocity, we know from special relativity that the answer will be c. Speed of light will be the same regardless of where you were at, okay? But let's just prove this. So we refer to equation 26-10 for the relativistic addition of velocities. This is for objects. This is for things that move at very fast speeds. And this is simply u equals v plus u prime over 1 plus v times u prime over c squared. Okay. And let me break down the terms here. U is the speed that observer on Earth measures for light beam. I'm sorry, some of the text got cut off over there. That's U. And then you have V, which is the speed of light with respect to the spaceship. And this will be negative c. Negative c because the light is moving away from the spaceship. So if it was moving in the same direction the spaceship was, this would be c. But since it's moving away, it's negative c. And then you have your u prime, which is the speed of spaceship with respect to the Earth. The spaceship, as we know, is moving away from the Earth at 0.7 c. So there is that. Okay. And now we can just plug in numbers to check whether or not this actually is c. So v is negative c. U prime is 0.7 times c. And then you have 1 plus negative c over here times 0.7 c over c squared. And you end up with something that looks like negative 0.3 c over 0.3. This gives you negative c. So what this means is that your observer will measure speed of light to be c, moving towards Earth. And that's it.